4-3 is the last section of chapter 4, and it introduces us to two more formulas. The main idea of the chapter focuses on binomial distribution formula. If you remember, binomial distribution formula was this. And we spend a lot of time on that formula, but they do throw two more in here to kind of introduce us. The first one is the geometric distribution. And the geometric distribution is an action that is repeated until success occurs. Like you keep trying until you're successful, where X is being that success. Okay, P and Q, you should already know what P and Q, that was in this formula. P is your probability of success. Q then is your probability of failure. Okay, so that's kind of, is that the first successful is the fifth one. The first successful would be then the third one. That's how you know what X is going to be. So let's do some examples of that. In the United States, approximately 42% of people have type A blood. So that 42%, that's my P, 42%. If 4 people are selected at random, find the probability that the fourth person is the first one selected with type A blood. Okay, so see how my first success is the fourth person, right? The fourth person is the first one selected with type A blood. That's my first success. Okay, so P would be 0.42. Q then would be what? 0.58. And I want it to the X minus 1. So that would be 4 minus 1, which is 3. Okay, so when you're putting this in the calculator, you do need to be careful of how you put this in your calculator, because what students do what students do wrong is they multiply and then take it to the power. Only the Q is going to that power. Okay, so if I were to put this in my calculator, I would have parentheses 0.42 times, and then parentheses 0.58 to the third power. And you should get 0.08, 0.082. Okay, so be careful when you're putting this in the calculator. Let's try another one. Basketball player Dwight Howard makes a free throw shot about 58% of the time. So using my formula here, P is the 58%. Find the probability that the first free throw shot he makes is the fourth shot. So the first success would be the fourth one. Okay, so again, I'd have 0.58. And the complement to 0.58 would be 0.42, and I would have it to the 4 minus 1, which is 3. So parentheses 0.58 times parentheses 0.42 to the third power, right? I'm just go ahead and simplify that. It'll make it a lot easier if I just do 4 minus 1 is 3. And you should get 0.043. How about this one? The first free throw shot he makes is the second or third. Okay, or means add. So let's do second. The second would be, right, P and Q stay the same, but what changes is the first success now is the second. So that's 2 minus 1, or means add. Third shot, again, same thing, right? But now it's 3 minus 1. And I'm going to add those two together. So 0.58 times 0.42 to the 1 plus, and I get 0.2436, and then 0.58 times 0.42 to the 2, and I get 0.1023. So add those together, and you get 0.346. Okay. He does not make his first 3 shots. So if he doesn't make his first 3 shots, what does that mean? His first success is maybe the 4th shot, or if his first success is the 5th shot, did he still miss the first 3? Yes. If his first success was the 10th shot, did he still miss the first 3? Yes. If his first successful shot was the 20th shot, did he still miss the first 3? Yes. So you can't solve it by this. You can't say the first success was the 4th one or the 5th one or the 6th one or the 7th one or the 8th one, because you keep going forever. So you have to do this one by the complement. Then the complement being that he did make one of the first 3 shots. Okay? So if I wanted the probability I did make one of the first 3 shots, I have 2nd or 3rd right here. Okay, so I'm going to do 1 minus, he did make one of the first 3. So he made the first one, or he made the second one, or he made the 3rd one. Okay, so if I said he made the first one, or second one, or 3rd one, the opposite of that would be he didn't make the first one, second one, or 3rd one. Okay, so I already have this one, 0.2436. I already have this one, 0.1023. So then I just need 1. So 0.58 times 0.42 to the 1 minus 1, which is 0. Anything to 0 power is 1. Okay, so add those together. Take 1 minus that, and I get 0.074. Okay, so that one, since it's an infinite possibilities, we don't have a limit, you have to do that one by the complement. Let's try one more. A person works in a large home improvement store and approaches customers to tell them about the store's carpet sale. He then asks them if they would like to talk to a sales rep. From past experience, the person has found that the probability of getting a yes is about 32%. Find the probability of the person's first yes will occur with the 5th customer. Okay, so see how this says the first success will be the 5th customer? That's kind of how you know that this is going to be a geometric probability. Okay, so 32% that they'll say yes. So what's the probability that they'll say no? 0.68. And I want the 5th customer. My first success will be the 5th customer, so 5 minus 1, which is 4. So 0.32 times 0.68 to the 4th power. Oops, and I think I typed that in wrong. Hold on. 0.068. Okay, so that's geometric probability. Geometric probability is a very simple formula. And how do you know if it's a geometric probability? It'll say something of a first successful. The first one happens at the 3rd. The first one is successful by the 9th one, and so on. So let's look at the second one today, and that's Poisson. It's French. Poisson distribution is kind of a bigger formula. Okay, this symbol here means average, right? So you could also look at it as like this, the average to the x value. E is a number on your calculator. Remember when you studied natural logs in Algebra 2, we also had an E. So if you look at your calculator, there should be an E button. And if you can't find the E button, E is like pi. It's an irrational number, and it's approximately 2.71828. Okay, but it's easier just to use the E button on your calculator, but that is the approximation for that. And then it's to the negative mean. So negative mean over, and remember what factorial is? We studied that also with permutations, combinations. Your factorial button, remember, is under math. And what a factorial button means is it just counts down. Remember that? 5 factorial then is 5 times 4 times 3 times 2 times 1. 3 factorial would be 3 times 2 times 1, and so on. Okay, so when you have a Poisson, you're going to get an average over a certain length of time or volume. They'll give you an average, an expected thing to see. Okay, expected number, specific number of occurrences that will take place within the unit, time, area, or volume. Okay, so let's do an example here. And let me write this formula down again. Okay, if there are 200 typographical errors randomly distributed in a 500-page manuscript, find the probability that a given page contains exactly 3 errors. Okay, so on average, right? On average, there are 200 typos, right? 200 typos. So what is the expected number per page? So 200 divided by 500, I can expect 0.4 errors per page. Okay, so that's the average, okay? So the average, x bar, would be 0.4. And I want to know there's 3 errors on that page. So x is 3. E, remember, is in your calculator, to the negative 0.4 over 3 factorial. Okay, so what you need to know for this formula is the average. And most of the time the average is given to you. You don't have to calculate it like we did here. E, remember, is, don't try to put a number in for E. E is a number. And you also need to know the x, right? What are you looking for? The probability of what? Okay, so putting this on my calculator, 0.4 cubed times e to the negative 0.4 divided by 3 factorial, and you should be able to do that in your head. 3 times 2 times 1 is 6. If not, you do have the factorial button. So I should get 0.007. And it should be a really small probability. To have 3 errors on one page, that should be a small probability. Okay, let's try another one. A sales firm receives on average 3 calls per average. So see how it tells me an average? I already know that there's an average here, that 3 calls per hour. So that is my average. Okay, for any given hour, find the probability to receive the following. At most 3 calls. At most means what? At most 3 means 3 or less. So that would be 3, 2, 1, or 0. Okay? So using this formula, we're going to just keep using this formula over and over again, and the only thing that's going to change is the x. The x is going to change. It'll be 3. So this would be, my average number is 3. So this one would be 3 to the 3 times e to the negative 3 over 3 factorial. Plus, this one would be 3 to the second times e to the negative 3 over 2 factorial. This one would be 3 to the 1 e to the negative 3 over 1 factorial. And this one would be 3 to the 0 e to the negative 3 over 0 factorial. Okay, so you notice the only thing that's changing is the x. The x, the power here in the denominator, 2, 2, 1, 1, 0, 0. So 3 to the third times e to the negative 3 divided by 6 again, right? 3 factorial is 6. So 0.224 plus, and then I'm going to do squared, and 2 factorial is just 2, so 0.224. And then 1, and 1 factorial is just 1, so 0.149. And what is 0 factorial? There's the question of the day, right? What is 0 factorial? And if you do it on your calculator, is it 0? Nope, 0 factorial is 1, right? If you did that in your calculator, you should know it. 0 factorial is 1, not 0. So 0.005. So I add those together, and I get 0.647. Right, so that's at most 3 calls. Okay, so at least 3 calls. At most 3 means 3 or less. At least 3 means 3 or more. So since I already have all this work, to do at least 3, I'm going to do it by the complement. At least 3 means 3 or more. So I want less than 3. So I'm going to take 1 minus the sum of those 3. That's the complement, right? Less than 3. So less than 3 would be the probability of the 2, the probability of the 1, and the probability of the 0. So 0.224, 0.149, and then 1 minus that would be 0.577. Okay, 5 or more calls, 5 or more, the opposite of 5 or more is what? Less than 5. So less than 5 would be 43210. I have 3210, so all I would need is 1 more. So 3 to the 4th, e to the negative 3 over 4 factorial. And add those with these that I already have, and that would be 5 or more. Okay? Because 5 or more, the number, that's another example of it's infinite. 5 or more, I could have 100, 1,000. So I have to do by the complement. So 3 to the 4th times e to the negative 3 divided by 4 factorial, which would be 4 times 3, which is 12, 12 times 2, 24, 24 times 1, 24, is 0.168. So I'm going to take 0.168 plus the 3210, which we already added those. That was the first one up here. So 0.647 plus the 1 more, 0.168. And then I'm going to do 1 minus that. So 5 or more would be 0.185. Okay, let's try another one. If approximately 2% of people in a room of 200 are left-handed, find the probability that exactly 5 people there are left-handed. Okay, so if 2% of 200 are left-handed, what is that expected number? So 2% of 200 is 4. So I can expect my average of 4 people. Okay? I know by using statistics, 4 people are going to be left-handed. So what's then the probability that it ends up being 5 people are left-handed? So my formula, my average, 4 to the 5th power e to the negative 4 over 5 factorial, right? That's my average, that's my x, and e, remember, is on your calculator. So 4 to the 5th times e to the negative 4 divided by 5 factorial, 0.156. Okay, so there's your other 2 formulas. So this is kind of what I tell students to write down. If you can, let's do this so you can see it better. Okay, this is what I kind of have students write down. I have them write all 3 of my probabilities down. This was my geometric, PQ times x to the n minus 1. Poisson, which is your average to the x times e to the negative average, x factorial. And here's my binomial, right? The one that I first learned. Okay, so when you're doing your homework, how do you know which is which? Because that's the hard part. Looking at these individually, it's not too bad. But when you're looking at 16 homework problems and you need to decide which formula to use, then it gets a little bit trickier. So here's my hints. When you're using geometric, you'll see keywords like your first success will be the 4th person. The first time this will happen will be the 3rd time, or so on. Okay, so you'll see those keywords. You know it's Poisson when you're given an average. It'll be the only problems that give you an average of occurrence. The average is 3 people. The average volume is 6 cubic inches, something like that. Binomial then, how do you know it's binomial, is you'll have a combination. 3 of the 4 people, 9 of the 10 puppies, 6 of the 8 oranges, something like that. You'll have it has to have a combination, okay? So that's kind of the key words, and your book also does a really good job. On page 219, on page 219 in your textbook, it does a really good job of narrowing each one down and giving a summary and the formula, okay, for binomial, geometric, and Poisson. So that's another good page to look at on page 219 in your book. So your homework for this section is page 220. And it's 11 through 26. And I'm going to give you a hint. 6 of those problems are geometric. 6 of them are Poisson. And 4 of them are binomial. Okay? So there's your hint of how many of each. Remember the odds are in the back of the book. That's a great place to check your answer. If you're still really not sure, send me an email and I'll help you kind of walk through it. But as long as you look for those key words, like is it talking about a first success? Is it giving me an average? I mean, it'll say the average is. Then you know it has to be Poisson. Or is it giving me a combination? Then you know which one to use. And really, once you know which formula to use, then it's fairly simple. You just plug P for P, Q for Q, the average for the average, and so on.